So we're starting on this install to fill this wall here, which is going to include a table. I get quite a lot of interest in the different types of levelling feet that we use, and this is one that I'm not sure if I've shown before, possibly in a video some time back. It's a two-part plastic thing with one part that just twists over the other to go up and down. So you see that one, that's around about the mid position, and that will thread up or down. I've run my levels on the floor and I found that the high point is at that far corner, which is quite common. And there's enough of a variation that what I'm going to do is just take the outer part of the foot off that back corner, so it's as short as it can be, and then level everything off that. Because we're aiming for a shadow gap, but we don't want it to come up too high over on this side. Now I'm finding I'm having to adjust the feet so much. I mean, this is the one at the opposite corner adjusted to level when this is laid down, opposite from that. It's such an adjustment that I think I'm going to run out of adjustment by the time I get over here. So I'm going to just shorten this foot by replacing it with sort of 12 mils worth of packers. You won't see that, so those may as well just be super glued on and just work as a support from which I'll level the rest of the feet. Well, this is where I'm up to. This countertop is about to be scribed so that it overhangs slightly less than it does now. The units are all secured. I've used space plugs over here. The door is a standard overlay hinge arrangement on this side, but on this side, because the unit, well, because it needs to open and clear the radiator and also a curtain that will be hanging down here, but the customer wanted to maximise the space, the side of the unit goes beyond the door hinging point, which means we've used these what are called post hinges. They're used in kitchens in similar places, like for corner cabinets and stuff. And the way they work is that in the closed position, they're sitting flush. The door is sitting flush, or in line, I should say, with the place that the mounting plate's fitted. So these ones are by Blum. Something to watch out for is the position of the mounting plates off the edge there is, I think it's 21 off the top of my head. You'll find it in the Blum catalogue. It's not the standard position for a mounting plate, so you could get caught out by that if you don't know that. So those doors are just going to need a little bit of tweaking in, but they're about right. My preferred sealant currently, I've talked about a few on the channel. Preferred one at the moment is Stick-Saw. It sticks and it seals. It seems to stay pretty white. It cleans off pretty well with wipes, but if you re-wet the wipe, it still cleans off, so you're not wasting too many wipes. So that's what I'm using where things hit the wall. So on to scribing that countertop next, then the other one, and then we've got the top units to put on and a few other scribes and cover panels. Now this is the first time we've used this particular type of bracket. This is a Hayfully bit of hardware, and we've done a test piece following the distance, which I think is 67 millimeters from there to this groove. However, what wasn't really clearly specified was the size of the chamfer on the oak leg there, and on doing this assembly we've realized that this chamfer is too small and needs to be set further back in order to ensure that the bracket pulls tight. So I think as long as there's a gap there and that's not ending up tight to the inner face of the apron, we're going to get a little bit of wobble on the legs, which is what we've got. The other challenge with a table assembly is ensuring wood movement for the top surface. So if we were to just screw this or glue it or even domino it to the top for rigidity, then the lack of movement in this frame, because timber along the grain doesn't really shrink and expand, so the rigidity of that would work against the natural shrinkage and expansion of the top, because in this direction, running across the grain or perpendicular to it, wood is always prone to movement with changes in temperature and humidity. So the way that we first got around it was by drilling oversized holes. So we've recessed them in, big enough for a washer and the head of a screw, and then the hole that the shank of the screw goes through is also oversized. So I can show you that a bit better on these bits. Now these are just little add-ons because it's quite a non-standard table which has an overhanging bit that goes over a bench seat for compactness, and then it pulls out when in use. So this is the joint we came up with. There would be a washer in there and a pan-headed screw screwing up into the top surface. Actually, we've decided that's not really necessary for these parts, so we're going to domino and glue these ones on anyway, because they can just be fixed to the underside of the table, and any shrinkage, it could just move slightly that way and not really be a big issue. Having assembled the table, we've decided we're not really happy with the strength that we'll get from these fixings, because the screws going up through those oversized holes will be trying to pull the material of the top down through the hole, rather than just pulling the apron. Well, they will pull the apron up tight to it, but we just don't feel that it's a long-term strong joint. So what we've decided to do is add on button fixings, as I think they're traditionally called. I'll show you some photos of them once Brady's got making them. But they will be something that will fit into, it can be a continuous groove, but we've decided to do it with the domino jointer. So there'll be a slot just set down about 9mm with this button that's a sort of rebated long grain piece that's screwed up through the body of itself into the table. And that'll be set in with a bit of a gap in such a way that the wood could move. So I'll show you that either with just photos dropped in or maybe another talk piece, and you should be able to see how that works. So Brady's cut the chamfer in a bit deeper on these legs, which has allowed the plates to pull them in tighter. He's also put the screws in there, which help it all to fix a bit stronger. He was having trouble taking these screws in and out, so these have a wood cutting thread on the other end of them, and they were getting difficult to get in and out with pliers, so he's, with the Dremel tool, he's put that little crosshead in the end of them. He's fitted these buttons, as they're called, traditional method of fixing the tabletop. So they're going to get screwed through with panhead Craig screws, and they go into a slot. You can just route a groove, but we decided to just do it with the domino jointer. So when they're fitted, they're going to be deliberately backed off about 3mm like that, screwed in, so that holds everything tight together, but that gap allows the shrinkage of the wood to move, so the tabletop effectively can float on top of the frame whilst being tied down. Now we've also added these struts across the middle, possibly a bit over-engineered, but we were finding that when the plates here were pulling the legs in tight, which is essential to the legs being rigid, especially considering that this table is going to be moved in and out a lot in use, we found that the force of the brackets pulling tight on the bolts was bowing these side pieces in, and because all of the fixings for the side pieces are deliberately floating, as we've just mentioned, it was going to be hard to stop that bow unless we put some cross pieces in. So that's the reason for them. So we now have a very rigid frame, so the legs and the frame will stand very secure and rigid on its own, and the tabletop can then float on it. And Brady's just about to put these domino fixings in so that this becomes very securely fixed, because as I think I discussed on the previous clip, we just felt that these fixings might not be quite enough really, because they're sunk in quite deep, and the screws are passing through that quite big hole, which might tend to drag the material up through it. So I'm confident this now is a very, very well built table. Brady's just put a spray coat on this tabletop. Now we have had a bit of a tough time getting the finish on this. We've been using a product from Finney's Wood Finishes, very nice satin acrylic varnish, which we've used with success before. But we've just been finding that it's been raising the grain a lot and we can't quite get the flatness of finish we wanted. We've been hand applying it. So we thought, well, let's get the final coat on with spray. So we set it up in the spray machine. We'd been avoiding that because it means filling the pump with this finish that we're not going to use for anything else. And Brady went ahead and put it on these trestles and sprayed it, and he then found that it was pooling down to one edge because it was on a bit of a slant. And I do remember being told that this, although this finish can spray well, it's not a spray finish in the sense that it is inclined to run. And I understand now how easily it does that. And it's really made the decision that I wouldn't go forward with this as a clear sprayed finish, because the ones from Movac that I've been trialling do stick and stay in place definitely much better. So what we've done is just pack this up on the trestles to nearer to level to let it dry off. But we've got some pooling here that's going to be a lump that's going to need a good deal of sanding back later. And this was meant to be the final coat before delivering this tomorrow, so we may have to delay that. It's also probably a thicker coat than we'd normally put on, I think, because it's coming out quicker, being a thinner finish. So we'll just have to wait and see if that's a problem. What I'm hoping is it'll be beneficial, because I think it's going to fill the pores in a lot better than we were getting off the brush coated thin layers. So I'm hoping this will denib back to a nice flat finish. So I'll just have to let you know. Well, this tabletop has been a little bit of a disaster because we just are not happy with the finish we're getting. We feel it's too plasticky and it's more textured than we really want it to be. We're regretting using this particular finish. To be fair, we have had good results with it actually, with those oak shelves with an angled base cover that I did a recent video on. But we just seem to get more grain raising with solid oak versus veneered, and I also didn't want to wax polish this. I just felt that finish wax on the tabletop just didn't seem right to me. I wanted it to be a simple hard wearing final finish. So anyway, we've just decided to sand it off, and what really sealed the deal was a member of our team, who shall remain nameless, has just dropped some hard MDF bits onto the edge. I've already dealt with a dent on the side by rail sawing a millimetre off, and this dent was deeper, but I've just swelled it with a bit of boiling water. So we just thought, right, let's send it right back, put on a finish that we know we can rely on, which will be this one that I used on the games table with 3198 from Movac, which also is very quick drying, so we should be able to get a good layer of that on, and it's hopefully then going to be ready to get out the door tomorrow. Here's a good shot for you of the finish that we achieved in the end. I think the multiple coats, I should say, that we put on did really help to fill in the grain, so it has helped us to get a very nice flat finish. It was a 10% matte finish, which we did then polish with a finishing polish, which is made for flattening off the finish rather than the type of wax polish that is made to go straight on wood. So that finishing polish was a Finney's product. It's very nice microcrystalline porous finishing wax. The rounded edges there are, as you can imagine, just to help ease it in, because care will need to be taken as this is pushed in and out of that space there. But overall, I think it's a quite distinctive and handsome looking project.